Hi everyone, this is Elad from Astrolab Diagnostics, and today I would like to talk about a subject that comes extremely often with the bioinformatics and biostatistics of cytometry data, and that is the impact of patient count on p-values. And I'm going to use patient, but you can talk about sample count, animal count if you're doing mice, and so on and so forth. And the common conundrum is, do I have enough patients to get significance? Setting that aside, given the patient count that I have, what are the p-values that I should expect? Now, to be honest, this is a pretty complicated question, and I had a previous video about how to think about significance and the thresholds people use. So I'm going to set all of the discussion aside and just focus on the p-values. So there is an oversimplification here, but please bear with me. And I'm going to generate a toy example using a study that I have demonstrated many times in these videos. This is a study on chikungunya patients that was done by Michel Meyer et al. As part of the Human Immune Project Consortium. And in this study, patients who were sick with chikungunya showed up at the clinic in Nicaragua, and blood samples were taken from them during two stages of the infection, the acute and convalescent stages. The goal is to compare the structure of the immune system between these two time points. And one of the summary figures from this paper is this visualization where every bar is one of the cell subsets. Bars that are below the line are overrepresented in the convalescent time point, and bars that are to the right above the x-axis are those that are represented in the acute time point. So convalescent and acute. And one of the subsets we see here are the naive CD8 T cells, which seem to be enriched in the convalescent. Another way to look at it, and this is how Astrolabe shows it, this is a box plot, and what we're seeing is the frequency of the naive CD8 T cells in each time point. The white line is the median, and it starts at 5% in the acute time points, and then goes up by twofold to 10% in the convalescent time point. Now, here is the game that we're going to play. We're going to ask, what if we had less patients? The full study has 42 patients in it. What I'm going to do, I'm going to take the top n patients for increasing values of n. 3 patients, 4 patients, up to 42. Then, for every sample count, I will calculate the p-value using the student's t-test, and I will compare the frequency of the naive CD8 T cells between the two time points. So to clarify, we already know the solution. We had 42 patients, and that gave us a p-value lower than 10 to the negative 13, and the trend was about a twofold change in the frequency of the compartment. What about the other values? Well, for 3, the p-value is 0.25. So if you take the 3 patients in the 3 first patient in the study, the three first patients that showed up at the door and whose blood was acquired, you will get a pretty abysmal p-value. What about the other patient counts? And again, the exercise here, n patients came through the door, the top n from the study, and these are the patients we're going to look at. In this figure, the x-axis is the number of patients, the y-axis is the p-value on the student's t-test. Here is 3 patients, and it's 0.25. Here is 42 patients, and it is 10 to the negative 13. Let's see what happens as the number of patients increase. So from 3 to 4, the p-value plummets by quite a bit. And then from 4 to 5, it goes below the mythic 0.05. So in an alternative universe where we only have the first 5 patients who walk through the door, we can say, aha, here is a significant trend in the naive CD8 T cell compartment. But now something a bit embarrassing happens. For the 6th patient, the p-value actually goes up to about 0.7 and 0.07. And in this alternative universe where we have just the first 6 patients, suddenly the trend that we identified goes away. I think this illustrates nicely the danger of setting an arbitrary threshold of 0.05 on your p-values. Setting that aside, the p-value has gone up. And then with patient 7, it goes down to about 0.025 and then about 0.2 if I recall correctly. Then there's a bit of a bump with the 9th patient that it goes up, and then it just keeps going down until somewhere around here it is low enough that we can safely say this is a significant trend. So just to answer the initial question, the impact of patient count, it is complicated. Like many things with analytics, the trend might not be as straightforward as you would think. And to me, the most important point is that more often than not, this might not matter. Your project has certain restrictions, whether it's funding, whether it's time, whether it's the number of patients or tissue that you can get from the hospital or a collaborator. And going back to the previous video that I did about significance, try not to focus too much on the p-value. When the time comes to write your paper, to submit your grant, there are tools out there that you can use to explain the trends, to explain the insights, to explain the hypotheses that you get from your data. The p-value is one of these tools. It is helpful, but it is also limited in many ways. And I hope that this little video helped you get a better grasp about the ways in which the p-value behaves. And with that, I will point out that you can subscribe to these videos on YouTube, and you can subscribe to our page on LinkedIn, and I will thank you for your time.